Hey, happy Friday afternoon, folks. I am recording this video just after lunch on Friday. As promised, I was going to put this up before I logged off for the weekend. So these last two problems have to do with completing a square for an ellipse. Now, this is going to feel a little different because if you take a look, I'm going to highlight this and I'll erase it. This is a 9x squared. This is a 4y squared. So that's going to change the way we do some completing the square slightly. So I'm going to erase this and then share with you how I would set this up. So let's start with the x terms. So the 9x squared and the 18x. I'm going to factor out that 9. So x squared plus, and that's going to be, oh, it just jumped on me. Sorry about that. So, shoot. All right. 9 and then times x squared plus 2x plus blank. All right, so now I'm going to do something similar with the y's. So I'm going to take out that 4. And the only reason I'm taking out a 4 is because it's 4y squared, and I want the y squared to be 1y squared. So this is going to be 4 times the quantity y squared minus 2y plus blank. Now, I still have that equals 23, but I am going to put in 2 blanks, just like I would for, say, the circle or like the parabola. We only did 1 blank when we were completing the square. Okay, so the process I'm going to use to find what goes in the blank is pretty similar. So, or actually it is the same. So I'm still going to look at this 2, divide it by 2, and I get 1. And then 1 squared is going to go here. Now here's the part that's going to be also a little bit different. What goes in this blue blank is actually going to be 9 times 1. It's the number in front that I pulled out times whatever I put in this blank. So let me show you how that works with this one. So I'm going to take that -2 and I'm going to divide it by 2. I get -1, and -1 times -1 is a +1. So this blank over here is going to be 4 times that +1. So 2 minor switches to our completing the square. One is that we have to factor out the number first, and then the second is when we're adding to the right side, we have to take into account that number we factored out. So most other stuff is going to work the same way. So it's going to be 9, and then the quantity of x plus 1, quantity squared, plus 4, and then this factors to y minus 1, quantity squared, equals, well, this is where I need a calculator because I'm going to do 23 plus 9. Well, that is 32, plus 4 is 36. Okay, we're getting closer. Where the 36 is, that needs to be a 1. So I'm going to divide everything by 36. So x squared plus 1, quantity squared. Well, 9/36 is just like 1/4. In my second set of parentheses, I'm going to have y minus 1 squared. When I think of 4/36 as a fraction, that's 1/9. And this will equal 1. Okay, so there is my equation. I'm going to just outline it in gray so it stands out. And that's going to really help me get everything for my graph. I know it said including foci up here. I'll get to that in a little bit. That is the hardest part. So center is -1, 1. So -1 and then up 1. So there's my center. And then this is telling me that my Rx is 2. Square root of 4 is 2. So that means from my center, I'm going to go right 2, and I'm going to go left 2. This is telling me that my radius in the y direction is 3, basically square root of 9. So I'm going to go up 3, put a dot, down 3, put a dot. Okay, so there is my ellipse. Okay, that actually didn't come out too bad. But it said to graph my foci as well. So to find my foci, I'm going to look under here, because remember I'm looking for that radius for the foci. I'm going to do the square root of bigger number minus smaller. So if I do 9 minus 4 under the square root, I get the square root of 5. Now, square root of 5 is a little bit bigger than 2, because I know the square root of 4 is 2, so square root of 5 will be a little bit bigger. So let me see, does it say to state the foci? No, just graph. Cool. All right, so I'm going to go 1, 2, and then just a little bit past that, there is a foci. I'm going to go 1, 2, a little bit past that, and there is a foci. So if I wanted those as coordinates, I would say they're -1, 1 plus square root of 5, and then -1, 1 minus square root of 5. If it was asking for coordinates. And just to be clear, the reason I went up and down from the center is because my y radius was bigger. So that's my major axis. Right. So that first part was probably the worst. Once we get to this gray box, it should feel kind of normal. But let's do another example. Okay, so a lot of 100s going on here, right? So, and things are grouped a little bit differently than they were in the last problem. So 4x squared and -40x. So I want to take a 4 out of both of those because I want a 1x squared. And then if I'm looking at the y's, I want this to be 1y squared. So I'm going to take out that 25. That's going to make this 100y into a 4y. And then I'm going to move the 100 to the other side. So -100. And then we're going to do plus a blank for the blue, plus a blank for the green. So there's my setup. And again, that may feel a little weird because we actually have a number in front of the parentheses. So now to try to fill in each of these blanks, and this should feel a little bit more normal. I'm going to take the -10 divided by 2, I get -5. So in the blank, I'm doing -5 times -5. Let me do the same thing over here with the green. 4 divided by 2 is 2. 2 squared, or 2 times 2 is 4. So we're used to just adding a 25 and a 4. But that's not quite right. We actually added 4 times 25. So I'm going to call this 4 times 25. And then for the green, we also added a 4 times 25, or 25 times 4, which, by the way, both of those are 100. So what I'm looking at for my equation is really -100 plus 100 plus 100. So 200 minus 100 means that's going to equal 100. Let's see what's going on over here. I'm going to have 4 times x minus 5 quantity squared plus 25 times y plus 2 quantity squared equals 100. So this should start to feel a little more familiar to an example we did in class today. So don't want the 100 there, I want a 1. I'm going to take to every term and divide it by 100. So I have x minus 5 quantity squared over 25 plus y plus 2 quantity squared over 4 equals 1. And again, I'm going to outline this in gray because that is really the equation that we're used to working with now for ellipses. So this is telling me that my center is 5, negative 2. So let me plot that. 1, 2, 3, 4, 5, and then 2 down. Okay, so let me do my r sub x. That 25 helps me get it. So 25, if I take the square root, that tells me my x radius is 5. So that means I'm going to count right 5 and left 5 from the center. So 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. Ooh, right on the y-axis. Okay, this is going to help me get my r sub y. So r sub y is going to be the square root of 4 or 2. So that means I'm going to go up 2, put a dot. I'm always moving from the center, and down 2 and put a dot. So if I really wanted to graph this ellipse, I'm pretty much done at this point graphing it. Let's go look. It says including the foci. Okay. So I need to find that r sub f. So I'm going to do the square root of bigger number minus smaller number. So bigger meaning 25, smaller being 4. And so this is the square root of 21. Okay, so square root of 21. That's going to be a little bit bigger than 4. Let's see exactly how big. So that's 4.6 approximately. So what does that mean as far as graphing? That 4.6, let's see, let me find a good color to do this in. Put in the blue. So this is like 4.6. So I'm going to go 1, 2, 3, 4, and then 0.6. Gosh, that's darn close. 1, 2, 3, 4, 0.6, probably about there. But those are going to be my foci. And again, I went right and left because that was my longer axis. If you want the coordinates for those foci, it's kind of funky, right? Because our center is not 0, 0. So this is going to be the coordinates. Let's see, it's going to be 5 plus the square root of 21, comma negative 2, and then 5 minus the square root of 21, comma negative 2. I'm getting this 5 from the center because I moved from the center. Okay, so I hope that helps kind of completing the square. It may still be a little fuzzy, so practice. Or if you want to, stop by on Monday during our Trevian Day hours, and we can talk homework questions. Have a great weekend, folks.